Okay, number 33 says solve the given equation and check. And that means we're trying to find the value of x. I have one underneath a radical sign and one outside. So to get the one that's underneath the radical out of that, I need to square that side, because a square and a radical cancel each other out. But remember, the rule is anything I do to one side, I have to do the other. So I also square that side. On the left-hand side, that gives me x plus 13. On the right-hand side, I have to square that sum. If you don't remember the rule for squaring a sum, then just go over to your scrap paper and put x plus 7, whoops, times x plus 7, because that, of course, is what x plus 7 squared means, and then FOIL it. If I FOIL it, I get x squared for first. Outer is plus 7x. Inner is plus 7x. Last is plus 49, which is x squared plus 14x plus 49. I would have just gone over and done that on my scrap paper to get that. But if I square the sum, the rule is square the first term, that's x squared. Multiply the first term times the last term, that's 7x, and then times 2, so that's plus 14x. Square the last term, that's plus 49, and you can see over here I got the same thing. So either if you remember the rule for squaring a sum, do that. If not, simply write them side by side and FOIL, and it doesn't matter. It takes you only an extra second to do the foiling. Okay, now I want to continue solving for x, so I'm going to move everything over to the same side of the equal sign. So I'm going to subtract x, and I'm going to subtract 13 over to this side, putting them below their like terms. These two cancel and give me 0 equals x squared plus 13x plus 36. That's a trinomial with no leading coefficient, so it's a simple factoring problem. I'm just going to use the method where I look for what multiplies to 36 and adds to 13, and that's 9 and 4. 9 times 4 is 36. 9 plus 4 is 13, so now I have 0 equals x plus 9 times x plus 4. I set each factor equal to 0 and solve. That gives me x equals negative 9. Put x plus 4 equal to 0 and solve, and that gives me x equals negative 4. Now remember, anytime, you should check all of your problems, of course, but anytime you have a variable under a radical and outside of one, you're very likely to end up with extraneous solutions, so you want to be really careful to check it. So the first thing I'm going to check is negative 9. So I have the square root of negative 9 plus 13 equals negative 9 plus 7. I'm plugging into my original equation, okay, before I'm squaring both sides. Negative 9 plus 13 is 4. That's the square root of 4 equals negative 2, and the square root of 4 is not negative 2, so it is the wrong answer, and negative 9 doesn't work. So now I'm going to check negative 4. When I plug in negative 4, I have the square root of negative 4 plus 13 equals negative 4 plus 7. Negative 4 plus 13 is 9. The square root of 9 is 3. Negative 4 plus 7 is 3. That does check. So that answer is correct, and my solution is x equals negative 4, because that one checks. There you go.